Hey first years, this is your captain speaking. This is our first online lecture, so let's give it a go. Today we're talking about soils. The first thing you do when you build a house is dig trenches and put foundations down. And up to 80% of all the problems experienced in buildings comes from foundations, poorly designed foundations and poor founding conditions. So what I want to do is look at this morning is the soil conditions around the Durban area. You can see from the map that you've got all sorts of soils, from the basalt in Lesotho to the dune sand at the coast and a whole bunch in between. There's about 6 main soil conditions in the Durban area, and we're going to go and have a look through them. But what I want to get into your brains, and this is exam or test stuff, so guys take notes, is that what's important in a soil is its bearing capacity. Bearing capacity, that means how much weight can the soil push against. You know, every action has an equal and opposite reaction. So when you build your foundation and you build a wall on top of it, that wall is heavy and it pushes down on the soil, and the soil pushes back up and everything's fine. If the soil can't push up enough, what happens? Your building will start to sink. Now, you might think that's crazy, but in fact, I actually had that situation on one of my jobs here in Winston Park where I live. The engineer who is supposed to test the bearing capacity of the trenches where you pour your foundations, he was away on leave. And so he just said, oh, it's okay. We built the walls up and the whole building started to sink. It was an extension to an existing house. We had to immediately go back, put in acroprops, pop them up, and the engineer was back from his leave. He came, he dug, he did a bearing capacity test, which we'll talk about later, and he discovered that yes, the soil was like butter. And so what do? You've got a foundation and it's sinking. What we had to do, we had to widen the foundations. Just like a pin is easier to go into a piece of polystyrene than a pen, because the pen is wider. We had to make wider foundations. Anyway, to cut to the chase, let's have a look at the soil conditions that we have in the greater Durban area. The first one is Berea Red. Berea Red is called red because it's red. You can see by the photograph that it has a very red consistency. Red in soil is always to do with an iron content, so the soil has got a high iron content. Berea Red is actually a great soil to build on. Firstly, it's easy to dig, to cut. You have things like excavators over there which need to cut into soil. Now, if your soil is too hard, if it's rock, that can be a problem as well. It might be good for bearing, but often on construction you need to change levels. You have to dig trenches for cables or for plumbing. So too hard rock can be as problematic as too soft rock. And Berea Red is just about perfect. It's got a reasonable bearing capacity. It drains well, and it's reasonably easy to cut. So there's our first one, Berea Red, which is good for founding on. Let's have a look at our next slide. This here is what's called decomposed granite. Another word for it is Umgani soil. It appears in the Drummond area around where I live, and if anything, it is probably the best possible soil in the world to build on. In fact, people dig the hillsides out around Drummond and sell the soil because it is so good and it's used in construction. So it's decomposed granite or Umgani soil. It's called Umgani soil because a lot of it comes from the Umgani River, where the decomposed granite is washed down into the rivers. Another picture of it is here. It's a bit small. You can see. Let's see if we can make this bigger. It's quite granular and it drains well. I actually use it for my bonsai. So if you guys are thinking of doing bonsai, I use Umgani soil exclusively. I mix nothing else with it. In fact, sometimes I even wash it to get the very fine particles out. But decomposed granite is a fantastic soil for building on. like I said. So we've got first Berea Red and secondly Doozy Gravel. Let's have a look at Doozy or Umgani Gravel or decomposed granite. Okay, next slide. Okay, how do we do this? There we go. Okay, the next picture we have here is sandstone. We get a lot of sandstone in our area. Sandstone is also another good soil to build on. It's decomposed sandstone. Sandstone, when it's exposed to sunlight, starts decomposing. So it might be hard and look pretty hard, but you'll find over time it does decompose. Let's find another picture for you. There's a picture of sandstone. It is quite hard if you start digging down. So it can be problematic if you're digging too deep and you hit sandstone. You might have to get your breaker in. What they use for hard rock is it's like a back actor or a TLB or one of those things that uses a big arm excavator. But what they do is they put a drill on the end. So it acts like a jackhammer, but it's a jackhammer on a big vehicle, and they actually pick into the rock, and that's the way they break it. So you could try rip it up with like a bulldozer with a single claw. If that fails, the next step up is to get your jackhammer, what I call a woodpecker. And if those two fail, your next item is to go to blast. Now, blasting is expensive. You need to inform the police. It's quite a mission. I've done it before on jobs. But if you've got a blast to get rid of your rock, then you know that you've designed badly. You should have designed around the rock. And that's one of the reasons to get a geotechnical engineer onto site to tell you what's underneath the ground before you have to start digging it. Right, let's have a look at our next one. Our next one is Dwight-Tillite. Now, funny enough, I'm actually building a building over Dwight-Tillite at the moment in Umlazi. So the Umlazi area has got Dwight-Tillite. Dwight-Tillite is very good for foundations. It's a rock, it's solid rock, it's strong. But there has been concerns on our construction that we might have trouble laying pipes, putting stuff underground. One of the things which I believe, which you can talk about in the next lecture, is that your foundations don't have to go down very deep, because the Dwight-Tillite has got surface soil above it in my project in Umlazi, and what I've said is that if the builder digs down and he doesn't go down as far as he wants to go for his foundations and he hits the Dwight-Tillite, he can just stop and build his foundations on it, because it's rock solid. Your building is not going anywhere. The problem occurs when you have got pipes like sewage pipes, which have to be to a fall. Then you've got to go into the Dwight-Tillite, and that's when you have to bring your jackhammers or pickers onto site to cut through the stuff. But that's our third one, Dwight-Tillite. No, sorry, that's our fourth one, Dwight-Tillite, and it's a very, very good rock to build on, but the danger is having to cut or trench through it. Right, okay, there's a picture of the Dwight-Tillite, and as you can see, we do have some of it going through the Durban area, and that's where I've hit it, just south of Durban there. Dwight-Tillite is also those rocks above the Umgani River. If you go north of Durban, you know there's some cliffs there where they've got that electrical power station. Those rocks are Dwight-Tillite as well. Okay, now we come to the black sheep of the family, the bad item. This is called Ecca Shale. That's spelled E-C-C-A, Ecca Shale. Ecca Shale is a sedimentary rock. I don't know if I talked to you guys about the different types of rock. We've got igneous, metamorphic, and sedimentary. Igneous is what comes out of volcanoes, it's like basalt. It's really hard. Your Duacatillite will also be that it's a very hard rock. Metamorphic is a rock which has been layered but has been under compression, and it changes its consistency. And then sedimentary rock is like sandstone. It's rock which is just, layered and become hard. So Eka shale, I think, is a metamorphic rock, but the problem with Eka shale, it's got a high clay consistency, and clay is your enemy, guys, because the problem with clay is when water gets into clay, the clay swells up. Now you want a foundation which is stable. If you've got something which has got a lot of clay in, it swells up and it can push your building up or down in patches. Eka shale, in fact, just turns into soap. So when it gets wet, it becomes soft like soap, and foundations just go straight through it. Eka shale occurs a lot around the hills of Pietermaritzburg. I don't know if you know that the N3 going up on the other side of Maritzburg, Town Hill, has had many problems because the N3 road was starting to slide down the hill, and that's due to the presence of Eka shale. I built some buildings above Pietermaritzburg on Eka shale, and we had to pile them. Now, what is piling? Piling is drilling holes deep down into the ground to get through the Eka shale onto strong founding, and we'll talk about that more in 2 lectures time, I think. So there we have the bad boy in the group. We've had 4 pretty good founding conditions, and now we come to Eka shale, which is very bad. If you see Eka shale on your site, you must just warn your client that he's in for an expensive foundation. There's another view of it. You can see it's quite striated, it's quite linear, like that. Okay, and there's our Eka shale group. You can see around above Pietermaritzburg, I was building just about there. So right in the middle of Eka shale. Bad stuff, keep away. Right, the last one is dune sand. Now, dune sand is also pretty poor for founding, although when you dig deeper, it does get better as you go deeper. This is a project of mine in Zimbali, up the north coast, near Belito, and we're building on dune sand. Look, as you can see, those things are for piles, so we had to pile, we had to dig down to stronger rock. So dune sand is a second bad one, not as bad as Eka shale, but it's like sand, it doesn't have much bearing capacity, it's not strong, and so it's going to need expensive foundations. It cuts easily, but then it also erodes. This project, we had a lot of problems with erosion. It was a very steep site, and the when you cut your banks and then you get a heavy rain, all your banks get eroded like this, and sand goes down onto the road, and then the Zimbali committee are jumping up and down and shouting at you, and so there are a few challenges when you come to building very close to the sea on dune sand. Alright guys, we're nearly done. There's another picture of sand that's in Belito itself, and you can see that it's very sand, it's very soft. Okay guys, I'm limited to 15 minutes on these lectures, and I think that's a good time because the files are not so big. They can be uploaded, downloaded quite easily, but I will limit my lectures to 15 minutes, and our next talk, which goes hand in hand in this one, is looking at foundations, looking at the way engineers design foundations to deal with very difficult soil conditions that occur. So that's me signing out for the first lecture. Sayonara.